we are taking a uniform rod. Okay, in this question I'm going to find the kinetic energy of a uniform rod AB. Okay, so they have given you that the velocity at A is UA and the velocity at B is UB. Then we have to show that the kinetic energy of the uniform rod is this much: 1 by 6 m UA square plus UA UB plus UB square, where m to the capital M is nothing but the mass of the rod. So here I'm taking 2AB, the length of the rod, and the velocity is UA is the velocity at A and UB is the velocity at B. Then we can find the velocity at the centroid, that is nothing but half UA plus UB. That is the average velocity at the centroid. So where G is the centroid. Now instead of finding for a uniform rod, we know that the, the uniform rod is equimomental to the three particles. If I put three particles, means two particles at the corner of the rod and one particle at the centroid, then the mass of the particle which is situated at the corner of the rod is m by 6, and the mass which is placed at the centroid of the rod is 2m by 3. So if I take these mass particles at the corner to m by 6 masses at the two corners and 2m by 3 masses at the centroid, then these two systems are equimomental. We have seen already this system will be equimomental. So we know already that the two systems are equimomental. So if the two systems are equimomental, they will have the same moment of inertia. So instead of finding the moment of inertia of a uniform rod, we are going to find the moment of inertia of these particles, three particles. So the first particle of mass, we have kinetic energy is nothing but half into mass into velocity square. So the mass at A of the rod is m by 6 UA square plus half m by 6 UB square, and the mass at the centroid. Okay, so you have half 2m by 3 UA plus UB by 2 whole thing square. So you try to simplify this. So after simplification, we get m by 12 UA square plus UB square plus UA square plus UB square plus 2 UA to UB. So you add this, we get 2A UA square plus 2 UB square plus 2 UA UB. So you take 2 common, so we get here m by 12 into 2. So we get UA square plus UB square plus UA UB. So this and this get cancelled, we get m by 6 UA square plus UB square plus UA UB. So that is nothing but the kinetic energy of the three particles which is equimomental to the rod. So since we get for these three particles the kinetic energy to be this, so the kinetic energy of the rod will be also this. So we have got the kinetic energy of the rod, we got to be m by 6 UA square plus UB square plus UA UB. Thank you.